Hey everybody, Mr. C here. This is part two of a video series about how to solve kinematics problems in different ways. So in video one, we took a velocity versus time graph, and I showed you three different ways to solve it. In today's video, I'm going to show you how to solve a simple kinematics problem using equations in multiple ways. So by the end of this video, you should be able to say to yourself, I can solve a kinematics problem in multiple different ways to both check my work and confirm my work. So let's consider the following question we're going to use as our example. Consider a car moving at a speed of 15 meters per second initially. It accelerates at a rate of 3 meters per second squared until it reaches a top speed of 21 meters per second. We're going to determine the displacement of the car over the interval of the acceleration. So right off the bat, notice that I've underlined some of the important physics words. Let's provide some labels to them. 15 meters per second is our initial velocity. The 3 is the acceleration A. The 21 meters per second is our final speed, and the displacement D is what we're trying to solve for. So I have some letters there. As we go through and solve these problems, we're going to be utilizing those letters. So the first technique is we make a list of letters and we just try to find an equation, plug and chug, and hopefully it works. So recalling the information, V final was 21 meters per second. V initial was 15 meters per second. The acceleration was 3 meters per second squared, and we were asked to solve for the unknown distance. By looking up those in the reference table, you can see that there is in fact an equation which allows us to solve this in one step, and that equation is velocity final squared equals initial velocity squared plus 2 times acceleration times displacement. If we plug in the values, 21 squared equals 15 squared plus 2 times 3 times displacement, we can go ahead and solve. 21 squared comes out to be 441. 15 squared comes out to be 225 plus 6 times d. We subtract over the 225 and divide by 6, and we get an answer of the displacement during that time interval is 36 meters. And so there is the solution to the kinematics problem done one way. What we're now going to do is resolve the kinematics problems, that same problem twice more, 2 different ways entirely, and come up with the same answer. So here's method 2 you might want to use. Well, maybe you just didn't see the VF squared equation. You say, okay, I want to have just some systematic way of solving this. I just want to solve for time first. And we're going to do that, and that totally works. So we copy down the information we know. We know VF is 21. We know VI is 15. We know the acceleration is 3. We don't know the distance. We're going to try to solve for that. So I'm going to put an unknown next to the distance. And we're going to try to solve for the time first. So I'm going to use an equation that has velocity final, velocity initial, acceleration, and has time in it to allow us to solve for time first. That equation ends up being VF equals VI plus AT. I write the equation, and then directly underneath, I plug in again. So 21 equals 15 plus 3 times t. 3 is the acceleration. I subtract over the 15 again, and I get 6. Divide by 3, and I get a time of 2 seconds. Meaning, it takes 2 seconds for the car to speed up from 15 meters per second to 21 meters per second. And in reality, if you look at this problem, it should make sense, because if your acceleration is 3 meters per second squared, that means every second your velocity is increasing by 3. So then after 1 second, you're going 18 meters per second. After 2 seconds, you're going 21 meters per second. So now that I have that time of 2 seconds, I can erase it down here, place in time equals 2 seconds, and use another equation with time to solve for the displacement. That equation ends up being distance equals initial velocity times time plus 1/2 acceleration times time squared. I go ahead and I plug in. So displacement equals my initial velocity, which is 15, times my time 2, plus 1/2 my acceleration, which is 3, times the 2 squared. Really be careful here. When I'm doing that 2 squared, you have to square just the time. So I'll do that last term first. So it's 1/2 times 3 times 4, okay? Plus 15 times 2, which is 30. Really be careful that you're only squaring that time. That's a really common mistake people make. So I do the 1/2 of 3 times 4, that comes up to be 6, plus the 30, and I get a displacement once again of 36 meters. This way, solving for time first. So there's two ways to solve this problem. I'm now going to show you the final way, which we haven't talked about too much in class, but is equally useful as well. And that is, I can find the average speed of the car during the acceleration portion, and then use the average speed equation. So the average speed equation is v bar, average speed, equals displacement or distance over time. So if the initial speed was, if the final speed was 21, the initial speed was 15, the average speed is simply the average of those two numbers, 21 plus 15 over 2, which comes out to be 18 meters per second. The time, as we showed previously, that it takes to speed up, we showed that to be 2 seconds. So I write the equation down, average speed equals distance over time, and then I plug in directly below. My average speed is 18 meters per second, equals my distance divided by a time of 2 seconds. I cross multiply, and I get, once again, distance is 2 times 18, or 36 meters. Once again, verifying the problem that I get 36 meters, and also showing one of the great things about physics is there's really more than one way to solve a problem. One of the fantastic things is all these equations work. So utilize more than one technique. Use it to check your work, confirm an answer. If you get stuck, there's multiple routes. Well, hope this helped, guys. Happy listening. Best of luck, and I'll talk to you guys soon.